So friends, welcome to this new session on level of service on two-lane roads. First, I will introduce the concept of level of service, general concept of level of service, and then we will focus on two-lane roads. So let me define. First of all, let me define what is level of service. It is a qualitative measure describing operational conditions within a traffic stream and their perception by motorists and or passengers. So when you travel on a road, how do you perceive the quality of your travel, the level of satisfaction given by your journey? That is level of service. It is a qualitative measure, but indirectly describe the satisfaction of the road users. And because it defines the satisfaction level, so these are the four parameters which are generally included in the definition of level of service: speed and travel time, freedom to maneuver, traffic interruptions, and comfort and convenience. Now here, speed and travel time will majorly controlled by traffic volume on the road and also by type of highway, whether it is a state highway, national highway, or some district road, because the speed limit depends upon the category of the road. Traffic interruptions. Traffic interruptions may be because of traffic volume or maybe because of some external factors like intersections. Now here, generally number of stops per kilometer or total delay caused to a passenger during journey is considered as the criteria for defining level of service. Now similarly, comfort and convenience, that depends upon traffic volume and traffic density, but it also depends on the road condition. A road with potholes or a very high value of unevenness will give uncomfortable and frustrating ride even on low volume roads. And therefore, these are the factors which are generally considered in defining the level of service on a road. Now, this level of service can be represented by either one or more than one parameter. It all depends upon type of facility, and these parameters are called measures of effectiveness. In general, each facility is evaluated based on 6 levels of service, starting from level of service A to level of service F, where A represents the best operating conditions and LOSF represents the worst condition. Now I will explain the meaning of each of these level of service through some photograph so that you can appreciate what is level of service A and what is F. Now level of service F, if you see this highway, there is only single vehicle or maybe two vehicles on a road, and you do not see the second vehicle or the next vehicle for a long distance. So every driver here is free to choose his own speed and free flow conditions exist. All vehicles are free to move at their desired speed. They are not impeded by any other factor on the road. Any incident, any breakdown occurring on the highway can be easily absorbed at this level of service. When traffic volumes increases slightly, then this is called level of service B. See the difference between the first photograph and the second photograph. Now you have number of vehicles, but still the gap between the vehicles is large enough to allow free movement of the vehicles. Ability to maneuver is slightly restricted, but drivers are generally able to choose their desired speed, to travel at their desired speed. Effects of incidents and breakdowns are easily absorbed in level of service B also. When traffic volume further increases, then the distance between two vehicles reduces, and that creates a restriction on freedom to maneuver. Lane changes becomes difficult because there is no space between the vehicles. When you change the lane, you need some gap between the vehicles, but gap is very restricted gap. At this level of service, the minor incidents can be absorbed, but they can cause deterioration in the service. And if this incident is for a longer period, then there may be long queue behind this blockade. At level of service D, although this photograph is taken from a multi-lane highway, but concept remains same. The density is high, traffic flow changing from stable condition to unstable condition. Unstable conditions means basically the speed is very low and freedom to maneuver is noticeably limited. Drivers do not have freedom to maneuver because gaps are very small and there is no space between vehicles to either overtake or to lane change. Even minor incidents cause queuing. Traffic stream cannot absorb disruptions. So if there is any breakdown situation, it can lead to very long queues of the vehicles. At level of service E, traffic moves at capacity. Operations here are very volatile, and there is no gap that can be used by the vehicles either for overtaking or for passing. Vehicles are closely spaced, and this is the flow at capacity. And in extreme condition, level of service like this can occur, which we call the breakdown situation or force flow situation. And this occurs when traffic incidents cause a temporary reduction in capacity or demand exceeds the capacity of the highway. So these are 6 levels of service. Now, simplest method of understanding the change in level of service with respect to traffic congestion on a road is given in IRC 64/1990. Now, what basically it suggests that this is the operating speed versus flow diagram, which is parabolic in nature. As traffic volume increases, the operating speed reduces. And when operating speed reduces, the drivers start feeling discomfort as well as restrictions. So this is the maximum flow, which we call the capacity of the highway, capacity of the road, and this is defined as the level of service E. Now above this portion, this is stable flow condition and this is unstable flow condition. So this part of speed flow curve is divided into 5 sections, and each section here represents a level of service A, B, C, D, E, and F. As I told you, this part of the speed flow relation where speed and flow both reduce, and in extreme condition both can become zero, and that we call the jam pack situation or breakdown situation. Now, if you see the literature, then you will find that there are several parameters which define level of service on 2-lane highways, and important among them are percent time spent following, PTSF. I will explain this parameter a little later. Number of followers and percent free flow speed. There are many more parameters. There are many more parameters, but volume capacity ratio is no longer in use to define level of service on two-lane highways. Now, this concept of level of service was introduced in 1965, and you might be knowing that most comprehensive and most widely acceptable document on capacity and level of service is Highway Capacity Manual of United States of America. And this manual was first published in 1950. Its second edition came in 1965, and in this edition, first time this level of service was introduced. And for two-lane highway, operating speed and volume capacity ratio were taken as the parameter to define the level of service. The third edition came in 1985, and here it was thought that V by C ratio is not a good parameter. Instead, percent time delay. How much delay, if you are taking up a journey of 1 hour, out of this 1 hour, how much time you spend on delay? Delay means basically when you are not able to reach your desirable speed. You are moving at a speed less than the desirable speed. And average travel speed. These are two parameters which were considered in 1985 manual. Then in 2000 it was changed to percent time spent following. On two-lane road, the traffic operation is peculiar. Peculiar in the sense that the demand for overtaking, demand for passing increases as the number of vehicles on the road increases. But the opportunities to overtake reduces with traffic volume. And therefore, how much time you spend following your leader, because you do not find a gap in the opposing stream to overtake. That was considered as a parameter which will define the satisfaction of the users, satisfaction of the drivers. And for that matter, headway less than 3 seconds was chosen to define whether you are following a vehicle or you are not following a vehicle. In 2010 edition of Highway Capacity Manual, the percent time spent following or percentage of follower, then average travel speed and percentage of free flow speed were considered for different types of highways. Even two-lane highway were categorized into 3 groups: class 1, class 2 and class 3, and LOS parameters were different. And in the latest edition of 2016, these parameters are retained. So this is the level of service criteria in Highway Capacity Manual of USA for two-lane road. Average travel speed you can find out from free flow speed. Free flow speed minus 0.0125 into total flow on the road. That is the directional flow plus opposing flow. Directional flow basically means that the direction of travel where you want to find out the ATS. So if it's a east-west highway, then whether you are interested in east-west direction or west-east direction, that will become the directional flow. But you have to basically add both direction flow here. Now this ATS you can find from this graph also. It's a linear variation for different free flow speeds, and for different values of two-way flow rate you can find out the average travel speed. This is the translation of this equation. Percent time spent following, that depends upon two-way flow rate, and this is exponential. This variation is exponential, and you can directly read values here, or you can calculate. A and B are two constants, and VD is the directional flow. It is not the total flow. a directional flow. Now, this table gives you the LOS criteria which is used in highway capacity manual of 2016 for class 1 highway, class 2 highway and class 3 highway. For class 1 highway, they have taken ATS and PTSF, the criteria for defining LOS from A to E. And for class 2 highways, it is only PTSF, percent time spent following. And for class 3 highway, it is PFFS. PFFS is the ratio of ATS to free flow speed. So ATS you can calculate from the earlier equation, from this equation, and free flow speed you can measure in the field. Free flow speed you can measure, both can be measured, ATS as well as free flow speed. Free flow speed is the speed of vehicles which are moving at headway more than 8 seconds. Now in Indian Highway Capacity Manual, what is given that the level of service parameter is number of followers divided by the capacity. Because if you see, this percent time is spent in following. For this parameter, the surrogate measure is the percentage of vehicles in following state. PF, percentage of vehicles which are in following state. During formulation of Indo-Highway Capacity Manual, it was found that number of followers is not really a good parameter because it will depend upon the traffic volume, no doubt, but it does not necessarily correlate with the traffic congestion because the capacity of the road will depend upon several parameters. We found that capacity of a 2-lane road can vary from 2400 PCU per hour to 3000 PCU per hour. And therefore, it was thought that NFPC, number of followers divided by the capacity of the road, is a better parameter to explain the level of service on 2-lane roads in India. And the method is given in the manual how to determine this number of followers. But the simple equation which is provided in the manual is that if you know the two-way traffic, volume in PCU per hour, you can use this equation to calculate number of followers in the traffic stream. Now, number of followers will depend upon the critical gap. What should be the headway? What should be the gap between two vehicles when you call a vehicle following its leader? And that critical gap also depend upon the traffic volume. This equation is used to calculate the critical gap. And this equation was then converted into number of followers. So number of followers divided by the capacity of the road will give you the NFPC. And these are the ranges of NFPC. And because in India, volume capacity ratio has been used for a long time to define LOS criteria, and therefore corresponding to each NFPC, a range of V by C ratio is also suggested in the manual for the convenience of field engineers. Now let us take one example to illustrate how LOS is determined by Indo-Highway Capacity Manual method as well as by US Highway Capacity Manual method. Let us take this example. A section of 2-lane road in a plain terrain has traffic volume of 900 PCU per hour. The directional split is 50-50. The carriageway width is 7 meter with 1.5 meter earthen shoulders. Now these parameters, these conditions are required to determine the capacity of the road. Estimate the level of service as per Indo-HCM method. This is the first part of the question. Now second part is that if free flow speed on the highway is 95 km per hour, or you can say 60 miles per hour, find out the LOS as per US highway capacity manual of 2016, assuming highway to be a class 3. Now that is how it is solved. The total flow here is given 900 PCU per hour, that is Q. So if you use this equation, you can find out number of followers 1.1742 into Q to the power 0.9306, and this gives you 659 PCU. Now this number of followers is to be divided by the capacity of the section. For a 7 meter wide road, 1.5 meter earthen shoulder and 50-50 directional split, this is almost a base condition, and for base condition the capacity value which is given in highway capacity manual is 2946 PCU per hour, and therefore NFPC is 0.224, and this NFPC is in the range of 0.16 to 0.25, and therefore level of service is B. Now if you see from the consideration of volume capacity ratio, now volume here is 900, capacity is 2946, and therefore V by C ratio is 0.305, and according to this table it is again in the range of 0.26 to 0.45, and therefore LOSB. Now if you take the second part of this question, what is the level of service as per highway capacity manual? Now the example problem here, you can find out ATS, average travel speed, which is free flow speed minus 0.0125 into total volume. You can find out it from this graph also. The free flow speed is 60 miles per hour, so second line from the top. The total volume is 900 somewhere here. So if you take this line, it will give you the ATS. You can calculate ATS from this equation. Putting VD plus V0 equal to 900, it gives you 48.8 mph for a free flow speed of 60. So percentage of free flow speed is ATS divided by free flow speed, that is 0.8125, or you can say 81.25. And as per this table, this falls in the range of level of service C. So as per SCM, this is level of service C. So friends, you can write your observations and questions in the comment box. If you want any particular topic to be discussed here, please do tell me. I will try to make a discussion session on that topic. Thank you very much.